Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on December 16, 2025, which was published about 2 days ago. This paper introduces OpenDataArena, an open platform that benchmarks the intrinsic value of post-training data, backed by experiments covering over 120 training datasets across 22 benchmarks, with more than 600 training runs and 40 million processed data points. The paper is titled OpenDataArena, a fair and open arena for benchmarking post-training dataset value. Okay, and the implications for how we evaluate and select fine-tuning data look quite significant. Also, the authors shared an OpenDataArena tool repo on GitHub, and it is basically the full pipeline behind the arena. You will find scripts for dataset scoring, supervised fine-tuning via Llama Factory, and benchmark evaluation via OpenCompass, plus quick start instructions and reproducible configs for common models and benchmarks. Figure 1 explains why OpenDataArena is more than a leaderboard, because it treats datasets like first-class objects you can measure and trace. This figure shows the full framework, with 4 connected components around a central hub. The top left block is the data value leaderboard, which standardizes train and evaluate comparisons. The top right block is the multi-dimension data scorer, which scores data along many quality axes so you can see what kind of data drives gains. Figure 2 explains how OpenDataArena turns a raw dataset into a comparable, evidence-based scorecard. This figure shows the full pipeline, which matters because the dataset stays the only thing that changes while training and evaluation stay fixed. The left panel is the data input layer, where data gets collected, normalized, and tagged by domain. The top panel is the data evaluation layer, where the unified train and evaluate run happens, and the multi-dimensional scorer produces quality signals. The bottom panel is the data analysis layer, which compares model-by-data effects and tracks dataset families, and the right panel is the data visualization layer for leaderboards and side-by-side comparisons. Figure 5 makes the data ecosystem feel concrete, because it shows what kinds of post-training datasets dominate and how those priorities shift over time. The left donut chart summarizes the full repository, and math takes the largest share at about 34%. The right stacked bars then show the quarterly mix, where code spikes in late 2023, math peaks in 2024, and science gradually climbs into 2025. Table 1 shows whether the same fine-tuning datasets stay good as you switch from QN 2.5 to QN 3. Spearman rank correlation means the agreement between two rankings, so higher values mean both models like the same datasets. The math row stands out because it is about 0.9, which signals strong consistency. The general row flips negative, so stronger models may treat generic instruction data as less helpful or even noisy. This figure shows which dataset quality signals actually predict benchmark gains, because it correlates scorer metrics with domain scores. The full heat map is the main object to focus on, and the strongest standout is that average response length aligns tightly with math performance. The code column flips that story, where longer responses correlate negatively with code results. Instruction-only clarity and coherence also skew negative in math, which reinforces that prompts alone do not carry the training value. Alright, 2 takeaways stand out. OpenDataArena makes post-training data measurable and comparable because the training and evaluation pipeline stays fixed while only the dataset changes. The results also suggest that response quality signals like how much useful work appears in answers often matter more than prompt polish, and the best recipe depends on the domain. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.